Hello my dear ICSE students. So, I have been observing there is a question in competency focused the booklet released by ICSE board. Many of you have asked this question, this tumbler problem, sir, that I have not been to Sandakfu or whatever, but this problem has come into my competency focused type problem, and I am not being able to understand the problem and the solution that is given in the booklet. So, first of all I would like to say there is nothing wrong in you are doing completely okay, because this diagram is very difficult to understand unless you have not heard of this technology earlier. If you have heard of this technology earlier, then it is an easy problem, otherwise the diagram is very bad diagram. The diagram could have been a much easier one, and so that students could understand exactly what is going on over here. To be very honest, this is not understandable. Okay. So, I will give you a simplified diagram for this, and after that we will try out this problem by ourselves and try to understand the concepts of physics behind it. Okay. So, please be with me. Okay. First of all, let me try to draw this in a simple terms rather than all these things. So, first of all, let me draw a door. So, in a door, suppose this is a door, right. So, here there are hinges in the door. Say this is one of the hinge and this is another hinge, and this is the top portion of the door, that is the frames of the door. You can understand what I am talking about. And it has been said that here in this frame, this is the rigid support, that is the frame of the door. You can understand what is the frame of the door, right? I do not know if I can show you this one. I will try. Okay, I will try to show some door. Okay, I think I can show you. Yeah, thank you. I think we can show this. See, this is the frame, the rigid support. Okay, so now you can identify what I am talking about over here. Okay, so I think the thing is clear right now. So from here, what I do is I put a nail onto this. Okay, I put a nail onto this. So here I am putting a nail. In Bengali, ekta perek pute dicchi, and from that I am hanging a rope with which there is a tumbler. Tumbler means simple bucket. Tumbrel and all those things, they just play with your English here, there is nothing. So, now it is relatable, I guess. Okay. So, coming back to normal, so let us see this one. So, when you say this one, so this is a closed door, right, this is a closed door. Now, the question is, on enquiring about the tumbrel, the owner of the tea house said that it acts as a pullback door closure after opening and releasing the door. So, I open the door, even I can show you in this one also. I can show you in over here also. If you see this one, I will show you this one. I have this system, you can see this. Now, I have released, it will automatically come back. Can you see this one? It is automatically coming back. So, door closer after releasing the system. Okay. Thank God I had this kind of door over here. So, how is this happening basically? So, I have to first of all concentrate on this part, do not concentrate on other parts, because this tumbler is hanged from a point. So, let us consider the point, let us consider the rope, and let us consider the tumbler, that is it, nothing else. So, what I will do? So, this is my fixed support, okay. It is where I have put the nail. From here I have the rope and I have the tumbler. This is my condition when the door is closed. Okay. So, this is the fixed point, this is the pivot, and just below the pivot the tumbler is there. The tumbler is giving a force that is nothing but force is equal to mg in this direction. Now, what does this force, how does this force affect this? So, this force is there exactly. If you draw the line of action of force, what will happen? If I draw the line of action of force, then the line of action of force is this one. Then the line of action of force is this one. Clear? It is exactly passing through the fixed point, that is pivot. So, when we talk about torque, that is moment of force, we say there is a fixed point, and from the fixed point if there is a force acting like this is the perpendicular distance, this is d, right. So, F into d is moment, but at this point of time if you see, here is the, compare this one with this one, here is the fixed point and the force is acting on the fixed point like this. So, what is d now? If it was here, say it is d1, now it is exactly on the pivot. So, I can say that here perpendicular distance d is equal to 0. So, no torque is acting, no torque is acting. So, here torque is 0 and hence the door remains as it is, no problem. So, how does it act as a pullback now? So, what I will do is I am going to remove this because this is not required for me. Can I remove this? Yes, I guess. Thank you. So, this is not required, I have removed this. Now, I will use this to understand the total system. It is very, very interesting, very interesting. Now, what happens? As the door opens, so now this door is opening. So, as this door is opening, so what is happening over here? Here is the fixed frame and the door is opening. So, I am trying to draw as much as I can. I am not a very good painter, I am sorry for that. Any skill that I do not have, I do not say that that is a matter of pride. I do not have that skill. I definitely try to develop that skill. Okay. So, this is the condition right now, the door is opened. From here, the rope is having this kind of turn and here is the tumbler, okay, with water. So, if I try to now draw this part separately, if I try to draw this part separately, then what happens? So, this is my pivot, this is my pivot. Now, the rope has become like this and this is the tumbler force or whatever you want to say it, that is acting like this. So, the force is now here. So, if I ask you what is the line of action of force, this is the line of action of force. This is the line of action of force. At this point of time, the line of action of force is not passing through pivot. And what I have to do to get the D? I have to draw a perpendicular. I have to draw a perpendicular over here like this. Yeah. Now, this is the perpendicular and so this will be my D now. Now, at this point of time, I cannot say that torque is 0. There will be some torque. So, this torque is nothing but F into D. And this is in which side? The torque will be applied in which side? The torque will be applied in this side. So, this is clockwise torque. So, as soon as there is clockwise torque, what will happen? This is going to fall. This is going to, as I am releasing, first of all I am giving some force, though this is happening. Now, I have released my force. Okay. So, what will happen? This is going to come down now. This is going to come down and so that this D reduces to 0. So, this will going to get back to its original position, because this thing is going to come down. This thing is going to come down below like this. This is going to come down and this d will become 0, because as it comes down, see here is the door, see here is the door. So, as it comes down, suppose it comes down a little bit, so what will happen, the door's part will be now at this part, say. So, now it has already come down. So, this, when you talk about this one, see now the perpendicular distance has reduced. So, as long as there will be torque, it is going to come down, down and down. Ultimately, the door will get closed, that will, it will attain this position where d will be is equal to 0 and torque will be is equal to 0. I will say, if you do not understand this, then please let me know in comments that you have not understood this one, because I understand that the primarily the figure was very poor given by ICSE, but now I think this should be clear to you, right. So, again there is another question that has been asked, what is the principle that is used. So, principle is principle of moments, that is because I am using clockwise anti-clockwise torque, that is it. So, this is based on principle of moments, but understanding is very important. Again, this is a problem on perpendicular distance between line of action of force and pivot. This is the main criteria. What is the basic concept that is required for this one, which may be asked in other questions also? Very simple. If there is a pivot, if there is a force acting around this like this, please from the pivot drop a perpendicular like this. This is your D. Okay, guys. So, I think you guys have understood this one. There should not be any further problem with this, and do let me know in comments if you have any doubts regarding this. Thank you very much. I hope I have clarified this.